We present to your attention a tuning fork calibration device, TFGD-4001, produced by High Precision Measurements. The device provides reproduction of dynamic deformation of a determined value and is used for calibration of measuring channels of strain, measuring equipment or data acquisition system, and also for checking the correctness of functioning of data acquisition system by connecting strain gauges to it that experience a deformation of a known magnitude. The principle of operation of the device consists in the following. There are tuning fork on the prongs of which are bonded strain gauges, the same as will be used on the measurement object itself. The device excites oscillations of the tuning fork at its resonance frequency, which causes deformation in the prongs. The device is powered by 5 volts through a regular cord with a Type-C connector, which allows it to be used also with power banks and makes it possible to work anywhere. Let's run the oscillation of tuning fork. You can see that the prongs of the tuning fork oscillates, but because the frequency of oscillation of the tuning fork prongs is quite high, so oscillations are hardly visible by the eye and badly transmitted by the camera. But to visualize the oscillations, we can illuminate the tuning fork prongs using a strobe light with a flash frequency close to the frequency of oscillation of the tuning fork. Quite an interesting picture, don't you think? To measure the magnitude of oscillations in this version of the device, an optical microscope is used. Also on the tuning fork, welded small plate with a tiny hole, which in the microscope is visible as a green luminous point due to the lower illumination, and when tuning fork oscillates, point blurs into a line whose length corresponds to the magnitude of oscillations of the tuning fork prong. In this case, it is 3 millimeters. Peak to peak. Knowing the magnitude of oscillations and geometric parameters of the tuning fork, the value of deformation at strain gauge bonded place can be calculated according to the corresponding formulas. In addition to the main function, device can also be used for fatigue testing of strain gauges. For this, proposed device is counting the number of cycles of deformation. Counting begins when the amplitude reaches 90% of the set amplitude. The set amplitude is adjusted with the buttons and set in abstract units of measurement. On display you can find the actual oscillation amplitude and oscillation frequency. In addition, in order to not constantly monitor the strain gauge integrity during fatigue life testing, with any kind of data acquisition system, our device provides the function of measuring and controlling the resistance of strain gauges. In this case, we have 3 strain gauges with 120 ohm resistance connected to the device. All strain gauges are connected in series, so the measured resistance is 363 ohm, which is equal to the sum of 3 strain gauges plus the resistance of wires. R1 shows the resistance that was at the time of starting the oscillations. If the resistance of strain gauges changes significantly or there is a break or short circuit of strain gauges, the device automatically stops oscillations. We can simulate change of resistance by connecting an ordinary resistor in parallel to one of the strain gauges. The device informs the user about the event and automatically stops oscillations and counting of oscillation cycles. Thank you for your attention.